Here we are, 9.3, graphing quadratic equations. First, I want you to notice that as I've evolved in learning how to use this program, I'm actually evolving it, doing these nice and neater now. So the first thing you need to do when you solve a quadratic equation is you need to use the formula right here. X is equal to 1/2 b divided by 2a. So if you don't know what A, B, and C are in the quadratic equations, this is A, this is B, and this is C. So that is the first thing you need to remember. So in this quadratic equation, in order to find the x of the vertex, or if you remember that the vertex is the part of the parabola where the very bottom or the very top, where the direction of the line changes, x is my x-intercept, or the place on my x-line where that vertex is. That just gives me the x. The x could be here, which this is 0. It could be here, which it could be 1. The x could be here, which could be -1. So that's what we're trying to look for. You're trying to find the x of the vertex. Let me erase this. So now, in this case, b is 10, and so I put it right up here. And a is is 5. Remember, I have to add the negative because there's a negative b there. And what I end up getting for is equal to x of my vertex. I have -10 over 10, because 2 times 5 is 10. And 10 divided by 10 is 1, which really gives me a -1. So my vertex, the x of my vertex, in this case is -1. Now here comes the tricky part. In order to find my y, because we all know that every point on a table has an x and it has a y. And in this case, in order to find my y, all I need to do is insert my newly found x into the x's that are there. And in this case, I'm going to put an x in here, and it goes in here. And I need to rewrite my problem as such. So I've rewritten my problem so that this x squared is a -1, and this x right here is 1. And now I have y is equal to 5 times -1 squared plus 10 times -1. And this is really, what's a -1 times a -1 is actually a +1, so this becomes 5 times a +1 becomes 5. Plus 10 times a -1, which becomes a -10. This could be written one of two different ways. Plus 7. Now, what is 5 plus a -10? Well, that is a -5 plus 7. And what's -5 plus 7 is actually a -2. So y is equal to a -2. So in this case, the vertex of this quadratic right here is, where's my x? -1, comma, +2, not -2. It's -1, comma, 2. That's the vertex, the very point of my quadratic. So, as you see, we've actually gone over here and we've done step 1, and now we've done step 2. And now I need to set up a table of values, and that's what I'm going to do right now. So as I set up my table of values, here's my x and my y, notice that I've put my -1 and 2, which is my vertex, in the middle of there. There's a method to my madness, and the reason is because I like to go one above, one below. So one above -1 is 0, one below is -2, one above 0 is 1, one below -2 is -3. There's a method, and you'll see in a second why. So now all I have to do is punch in my numbers into my original formula, which is, and here I've just plugged in my 1 into my formula. Here's my original formula, which is this right here. And I put a 1, sorry, I should put a -1 here. Sorry, I messed this up. Let me stop. There I am. I fixed it to make it to my convenience. I use the one above, which is 0 first. Why? because it's easy. What's 0 squared? 0 times 5 is 5. Plus 10 times 0, which is 0, plus 7. Right? And in this case, what this gives me is, oh, sorry, and I already made a mistake. 0 squared is 0 times 5. 0 times 5 is 0. Plus 0 plus 7 gives me an answer of 7. So y is equal to 7. And, in fact, here goes the 7. Okay? Let me do the one below, and you're going to see something weird. So the one below is, now I'm going to plug in y is equal to 5 times a negative 2 plus 10 times a negative 2 plus 7. This can be interesting because people always get freaked out by this. I got the wrong answer, but really, a negative 2 times 5 gives me a negative 10 plus 10 times a negative 2 gives me a negative. Oh, sorry, I did that wrong already. This should be squared. That's why I didn't look right. 5 squared gives me 4, positive 4, times 5 gives me positive 20, plus 10 times a negative 2 gives me a negative 20, plus 7. Negative 20 plus a negative 20 gives me 0, plus 7 gives me 7, which gives me y is equal to 7. Now everybody's going to go, wait a minute, how come I got the same answer for both of these? This doesn't make any sense. Well, if you think of a parabola, this will make sense, because if you think of a parabola, and in this case, they are symmetrical. Whenever you have a point on this x, you should get the same exact point on this x. And this point on this x right over here should be the same on the opposite side, and it's symmetrical. And this shows the symmetry of the parabolas, which are absolutely beautiful. I'm going to do one more, which I'm going to do 1 into this formula. Hopefully I won't make any more math errors. Here I am trying to speed up this video a little bit longer, quicker. So 1 squared is 1, times 5 is 5. 1 times 10 is 10. 7, just bring it down. 5 plus 10 is 15, plus 7 is 22, and in this case, 1 is 22. So I guess your prediction is, what should negative 3 be, since it's symmetrically opposite? The prediction should be that it is 22. Let me make that a little bit neater. So I want you to pause the video right now, and I want you to try to find this negative 3. So here's the last bit of this. A negative 3 squared, because you plugged in a negative 3 from here, is 9. 9 times 5 is 45. 10 times a negative 3 gives me a negative 30. And plus 7, bring down to 7. Now 45 plus a negative 30 plus 7. 45 plus a negative 30 gives me 15, plus 7 gives me 22, and voila, the symmetry of the parabola has been accomplished. Now remember, this parabola, since it is positive right here, right, this parabola moves up. If the parabola was negative, it would go in a negative section, and people get always confused on this because it seems to be going opposite. So as long as you put this vertex right in the middle, you should know that if you're evenly distributed above and below the vertex based on the x, you should have symmetry. And if you don't, you've made a math error. So you need to try this with some other problems, and here, I'll teach you guys. Thank you.